Get everything started.
You might make a dozen if we count.
So we're going to count us. You're right.
Silence, if you're around, can you come to the office?
Was it something we said?
That was
Come
late.
on, stick around for the presentation. Seriously, why not?
We gotta go see the seaplanes.
Well, they're right here. You can sit and watch the presentation and watch the seaplanes.
Don't forget Wayne's credit.
Just left.
Yeah, I thought it did. I guess we can get started. Good afternoon, everyone.
Hello.
My name is Rick Stevens. I'm the FAST Team Program Manager for the Wichita, Kansas FSDO. We're here this afternoon at the lovely seaplane base. Welcome. A lot of fun to be here. It's a nice place to relax and come just, this is a terrible way to have to spend the day, especially when they're paying me. Makes it even more fun, right? So what we're going to have today is we're going to have Mr. Larry Bothe, and he's going to be talking about fly the easy way. That's always the best way, isn't it?
Yes.
I like flying the easy way.
Everyone does it.
Larry is a past designated pilot examiner. He's currently a lead FAST team representative, which the representatives help us as FAST team program managers to reach out further. If you're interested, contact your local FAST team program manager in the office in your area. Maybe entertain you to put you in as a FAST team rep, and you're really helpful. He's also a Gold Seal instructor in Southern Indiana. He's rated in airplane single engine land. The seaplane?
Yeah, I'm not an imposter.
Yep. Multi-engine land, helicopters and gliders. He's also a Master Certified Flight Instructor Emeritus, FAA Master Pilot, and has 9,000 hours in more than 100 types of aircraft. He's half owner of a 1961 7 EC Champ and may be contacted at Larry Bothe at Comcast.net. I'm sure you'll put that back up on the screen later, right?
It's on the last slide.
Okay. At that, I'm going to come around and pass out some Wings credit forms. get you guys to fill those out. We'll take them back. We'll get you wings credit for this. One other quick thing. Do I have any pilots in here that have been doing it for a few years? What year did you solo? What year did you solo?
1973.
Okay. Have you gotten your Master Pilot Award
Where I come from, we don't have.
for flying 50 years? Do you know we give an award for
It's
that?
called a coffin.
Do you know we give an award for that, right?
No, I didn't know.
Contact your local fast team representative or get one of us, and we will be more than glad to point you in the right direction to get that award. It's a really good award. It's not tough to get. It takes, what, a page and a half nomination form, 3 letters of recommendation, and a history. Can you do that? Well, probably the hardest part is finding 3 people to say they know you.
Sorry?
Finding 3 people to say they know you.
Well, yes.
So,
That's the easy
with
part.
that,
Get him to say something nice about me, Mike.
Okay.
I would like to present you with a certificate of appreciation from the FAST team for helping us today with this presentation.
Thank you.
That's it. I'll put that over there. Your coat. All right, it's all yours.
Okay.
Should slide
Much
out.
rather hold that.
You got it?
I think you have at least some extra.
A little bit, not a whole lot.
All right, I turned on the PA system. So, anyway, Rick, thank you for the nice introduction. It's good to be back out here at the seaplane base again. We were talking earlier while we were setting up. I think that I hold the record for the biggest audience in this venue. Were any of you here when the Martin Mars big water bomber was anchored out here? Lots of people came to the seaplane base to see the Martin Mars, not me. But they came in when we started doing the presentation, so that's how I got 57 people in here. Anyway, not quite that many here today. So today we want to talk about flying the easy way. And Rick said, well, doesn't everyone fly the easy way? And the answer is not really. Some people work really hard to fly their airplanes when it's not necessary. And along the way, they spend extra money. So let's see. Okay, so Rick introduced me, so we won't read this stuff again. And so here's what we're going to talk about today. I want to explain why I do this presentation, and then we want to talk about some of these easier ways to fly. We'll talk about things you can do with trim in your airplane, mixture and throttle, radios and instruments, rudder usage, how to make short field and soft field landings work easy and right every time, and then at the end we'll do a few quick hits of stuff that makes flying easier, and then we'll have time for some questions, I'm sure. Okay, so let's change slides here. So anyway, why do I do this presentation? So I'm a flight instructor, and I do a lot of flight reviews. So I fly with other people, not people that I taught to fly. And some people are just working their tails off trying to make their airplane do what they want it to do. And there are easier ways. A lot of things instructors don't teach, even though they know it themselves. They just don't think maybe it's part of the private pilot curriculum. And they think maybe they need to make people do stuff the hard way first. They have to pay their dues before they can learn the secrets. Well, I'm going to let the secrets out. And you know what though? If you read the trade papers, the completion rate for people who start to take flying lessons is terrible. Only about 30% of the people who start taking lessons end up getting their first pilot certificate. The other 70% drop out. And part of it is that instructors aren't telling them how to do things the easy way. They make them struggle. And it's not really right. So I'm I don't like to see that, so I want to talk about the easy way. So we have 22 things to talk about today that is going to make your flying easier, safer, cheaper, and a whole lot more fun because it's not aggravating. So we'll start out doing tricks with trim. All right, so one of the first things you learn to do when you learn to take off is you set the trim control in your airplane for takeoff. And all airplanes generally have a mark where you set the trim indicator in the airplane for takeoff. But you know what? Stuff wears out in older airplanes, and very often the trim indicator, the mark isn't in the right place. And also, the right place changes depending on how your airplane is loaded. If you fly a Cessna Skyhawk, if you have 4 people in it, maybe the trim indicator is in the right place. But people hardly ever fly with the seat's full, they typically fly with a friend. Then it's in a different place. So here's what you do to learn about trim so that you don't have to fuss with it after you take off. So since you don't know any different, take off with a set where it's just set for takeoff, where the manufacturer said, and then set the airplane in climb, and then you adjust the trim so it flies at whatever your desired climb speed is, maybe 80 knots. When it's flying and climbing smoothly and at the right rate, look down and see where the trim indicator is set now. In my picture, the trim indicator is just by the O in the word off. Remember what that is. The next time you take off, set the trim indicator in that place. Never mind the little caret or arrow. Then when you take off, you don't have to adjust the trim after that until you level off into cruise flight. It's much easier. You don't have to fool around with it. Okay. Here's the number one thing that people do the hard way. So I'll tell you this at the beginning, and then if you're really bored, you can get up and leave because you got all the information you came for. Now, seriously, people make leveling off from climbing to cruise really difficult. What most people do, and because their instructor told them, is when they get near their desired altitude, say, guess 3,000 feet, they reach for the throttle and they retard the throttle back to the cruise power setting that they were told was probably worked pretty well for them. And so right away the airplane kind of stops climbing and it actually struggles to get all the way to the altitude that they want. Then they lower the nose to level flight, and then they set the trim. Oh, but wait a minute. If you were climbing at 80 knots and your airplane cruises at 105 knots, you're nowhere near at cruise speed, right? And you didn't give the airplane a chance to accelerate. So now, because you retarded the throttle, it has no excess power. So it creeps up towards cruise speed. But as it gains speed, airflow is higher over the wing, you generate more lift, so it starts climbing. You go, oh, rats, and you lower the nose some more. Maybe you move the trim a little. Now the propeller unloads, so the power setting goes up. You're not turning 2,300 anymore, you're turning, say, 2,400. So you go, oh, phooey, and you retard the throttle the extra 100 RPM. Well, it may stop climbing, but at this point, generally they start descending a little. So without dragging this out too long, what happens is people go through the air flying their airplane like a porpoise trying to get it into level cruise flight, and it literally takes 2 or 3 minutes for it to settle down. And during that time, you're changing the power, changing the trim, changing the attitude, and maybe saying bad words under your breath. So don't do that. What you need to do is what do you do as you approach your desired cruise altitude? First of all, let me go back here, I got ahead of myself. First of all, as you approach cruise altitude, don't touch anything. Leave the throttle wide open. When you get to cruise altitude, don't touch anything. Let the airplane keep climbing a little. Go 50 feet too high on purpose. When you get 50 feet above your desired cruise altitude, push forward on the control wheel or the stick all the way to put the airplane in level flight and hold it in level flight. Now what happens, the throttle is still wide open, right? It has excess power. So immediately it begins to accelerate toward the desired cruise speed. And it doesn't take long to get there because the throttle is still wide open. Now it goes faster, it'll generate more lift, so you have to push forward on the control wheel a little harder to keep it in level flight. But do that. If it gets to be a pain to do that, reach down like in a Cessna and move the trim wheel once from the bottom to the top, the part that sticks out of the console, to relieve the pressure. But the key is wait until the airplane reaches cruise speed before you reduce the power. And it doesn't take long, like 5 or 10 seconds. Then set the power for cruise. Now, because it's already accelerated, the RPM won't change because the speed's already up. So once you set the power, now reach down and fine tune the trim and you're in level cruise flight. Time 10 to 15 seconds total without much fiddling. It's way easier than adjusting that other stuff at the beginning and fussing with the airplane for 2 or 3 minutes. Don't forget to lean the mixture when you have a chance. Okay, a subset of this is how about doing a cruise descent from level cruise flight? Air traffic control tells you to descend and maintain 3,000 feet. Don't touch the trim. Don't enrich in the mixture yet. So then how much do you want to reduce the power? 300 RPM from whatever cruise power setting is, or if you're flying an airplane with a constant speed prop, say take off 3 inches of manifold pressure. And let the airplane, and the nose will drop by itself. So let it seek how it wants to descend. Typically you might get 500 or 600 feet a minute, which is a nice comfortable descent, but it won't hurt your passengers' ears and it won't look dangerous like you're diving at the ground. Okay, so for an example, say you get 600 feet a minute. Take 10% of that. 10% would be 60. As you approach your desired ending altitude, where ATC told you to descend, or pattern altitude at the airport, if that's what you're trying to achieve, 60 feet before you get to the desired altitude, smoothly but promptly bring the power up to wherever it was when you were cruising at the higher altitude. If it's a skyhook, just bring it back up to 2,300 RPM from 2,000. The airplane, the nose will come up all by itself because you didn't monkey with the trim, and you'll be in level flight at the lower altitude. Once you get down, then enrich the mixture because the air will be denser at the lower altitude. The airplane just levels off by itself. What you're doing is making the airframe work for you. It's much easier than you working for the airframe. Another trim thing, what do you do if the engine quits? Nobody likes to hear about engine failure, right? Not pleasant. I've been through a few. So the first thing we do is we pitch for and fly at generally the best glide speed, which allows you to go the most distance forward for every foot of altitude you lose, because you're trying to get to some good landing site to put it on the ground. Okay. And you want to trim for that, because you're going to go through another checklist, right? You have a checklist to go through to see if you can make the engine run again. And you'd like the airplane to take care of itself. And you don't want to have to worry about airspeed, but you certainly don't want to stall either. So what works best is you just simply move the trim wheel or trim control, whatever it has, to full nose up. And at this point, when I have a big audience, I get groans. People go, it'll trim stall. No, it won't do a trim stall. Single engine airplanes trimmed full nose up, power off, fly very close to their best glide speed. Best glide in a Skyhawk, for example, is 65 knots, and most of them full nose up fly at like 63 knots. It's really close. So if you don't believe me, go to altitude next time you fly and recharge, and a nice, safe, high altitude, recharge your throttle to idle, put on the carb heat if your POH says so, and then trim it full nose up and let it seek its own airspeed and nose attitude and see how it flies. And you'll find out that it flies very nicely at that speed. Then, and in a real engine out situation, now the airspeed takes care of itself, and you can worry about the other stuff in your checklist about fuel on fullest tank and, checking the mags and all the stuff that you're supposed to do to see if you can get the darn thing to run again. Mostly it's fuel, change tanks. Okay, talk a little bit, let's talk about mixture and throttle. When should you lean the mixture? Well, the answer you get to that is mostly whatever the instructor told you when you learned to fly. Instructors are often pretty lazy and they don't want to teach stuff. So they tell students things like, well, you don't have to worry about that mixture control below 5,000 feet. If you're below 5,000, just leave it full rich. That just means they don't have to teach it, but it's not the right answer. Sometimes I get 3,000 feet. The real answer is, anytime you're in level cruise flight, regardless of altitude, once you get the airplane into level flight, trimmed out, then you should lean the mixture. So, the benefit of that, we'll go back, the benefit of doing that is if you set the mixture properly, your spark plugs stay clean, you don't get a bunch of lead and carbon fouling, you get complete combustion. Oh, by the way, you burn a lot less fuel, so you don't spend as much to fly around. So leaning the mixture is an important function. So if you haven't been in the habit of leaning the mixture when you're in cruise flight, read your POH, talk to your instructor, learn how to do it. Okay, how about another time? You should lean the mixture on the ground after you get your engine started and it's running smoothly, because most airplanes run very rich at idle or close to idle, like taxi power. Cessna at the factory teaches what they call a two-finger lean, but the first time you do it, you should lean very carefully, watching the tack, lean it till the engine falters, and then screw the mixture back in till it runs smoothly, and then taxi around at that with that mixture setting. But what you'll find out is as you go through doing that almost always the mixture control is out the width of two fingers. So that's why Cessna calls it the two-finger lean. And once again, you won't save a lot of fuel because you don't burn much fuel taxiing around to start with. But will certainly prevent your spark plugs from fouling. What happens if you do a mag check? Keep my finger off the computer's pad for the mouse, I'll be in much better shape. If you get a bad mag check and the engine runs real rough on the either left or right mag, it means you have a fouled spark plug, right? What do you do about that? Well, if you don't know any different, you might take it back to the maintenance shop and forget your flight that day and ask the mechanic to look at it and tell your mechanic, oh boy, it really ran rough when I tried the left mag. But the truth is, you can 9 times out of 10 fix it yourself. You can do what's called a burnout. And to perform that, you go back to both mags, bring the power up to 2,000 RPM, screw the mixture out until the engine falters, enrichen it until it runs smoothly, and then just sit there for 20 seconds. It feels like a very long time, by the way, when you're waiting for the 20 seconds, but it's not, it's just 20 seconds. After you do it for 20 seconds, go back to full rich, set the power setting for where you're supposed to set it to do your mag check, say 17 or 18 RPM, and check it again. 9 times out of 10, it's cleared and the engine will run smoothly because you ran the combustion temperature way up for the 20 seconds when you were running at 2,000 as lean as it would run smoothly, and the carbon and crud burns away from the fouled spark plug, and you're good to go. And you can go make your flight, and you don't have to pay the mechanic. Now, you can also do that if you really get stuck and won't clear. You can also do that at full throttle. But that's like the last result is what you can do yourself as a pilot and get it to clear right away. If you try the same thing at full throttle and it won't clear, time to go to the shop and pay the mechanic. How about starting the engine when it's already warmed up? You fly somewhere for lunch, you go in a restaurant, you're there for an hour, you come back out. Some airplanes are pretty hard to start when they're warm. The problem is the engine is cooled off a little bit, but it's not really cold. And what it wants is a little bit of extra fuel to help it get started. But if you use the primer, often you over-prime it and flood it. So you can do it. Most airplanes have an accelerator pump in the carburetor. We're doing carbureted engines now. We're not doing fuel injection. If you stroke the throttle, it squirts fuel into the carburetor. Now, the carburetor's on the bottom of the engine, right? And so it squirts in there, and if nothing else is going on, gravity takes over, and it runs down into the carburetor air box. That's bad, because if the engine backfires on start, it'll set the fuel in the carburetor air box on fire, and if there's a lot of it, you have an engine fire. So that's really bad. But if you'd like to use the accelerator pump to just add a little extra fuel, you set the mixture at full rich, start with the throttle all the way out, and turn the key or push the button to get the engine to turn over in the start sequence. After the propeller starts to rotate, stroke the throttle once, push the throttle briskly all the way into the stop, and then pull it all the way back out to the stop. Now, generally they'll start while you're pulling it out, but pull it all the way back out anyway. If you're pulling it out and you're like halfway out and you go, oh, it's running, and you stop moving it, the engine starts with a heck of a roar. You don't want that. Pull it all the way out and then push it back in a 1/4 inch, and your engine will be sitting there running nicely, and it'll have been really easy to start. But I want to emphasize that you can only stroke the throttle and use the accelerator pump to apply extra fuel when the engine is turning over, because when it's turning over, it's sucking air in through the carburetor, and it takes that extra fuel directly into the cylinders where it needs to be to help the engine start. It does not run down into the carburetor airbox. So people that get in the airplane are going to start the airplane, and for whatever reason don't want to use the primer, which is what it's intended for, and instead they sit there and they pump the throttle 2 or 3 times. They are looking for an engine, without it turning over, they're looking for an engine fire. That's really bad to do. Don't do that. Talk about radios and instruments a little. You should set your radios up on the ground, and I don't care whether it's a GPS or you're using VOR navigation or whatever means of electronic navigation you intend to use, set it up on the ground. And the same thing with communications radios. You're going to set it up for whoever you need to be talking to taxi around, but you can also set it up for the next frequency you're going to go to after the one you're presently talking on. Most modern radios will deal with a couple frequencies at the same time. Setting it up on the ground while you're not having to fly the airplane is much safer. First of all, you're not looking down at the radios after you took off when you need to be looking outside for traffic. It's bad to be messing with electronics in any time in or near an airport pattern. You need to look outside. And the second thing is you don't make mistakes, because when you do it in the air, you know darn well you'll be looking outside. Then you're trying to do it real fast. And then you make mistakes, you put in the wrong frequency, put in the wrong heading, whatever. So it eliminates errors. Set radios up on the ground and then take off. And by the way, from a pilot examiner perspective, I wasn't very happy when people would take off and then start putting radio information in their airplane while they were flying. That's getting pretty close to cause for failure. If you're using VOR navigation, it's like, what's VOR? Everybody's got GPS now. Even in my Champ, I have GPS. But if you're using it, what course do you put in the course deviation indicator? You want to fly? If you're doing navigation the old way, and you sit down with a chart and you figure out what the true course is, and you get magnetic variation, then you do wind correction, and pretty soon you come up with a course that you're going to fly, right? That's not what you put in the CDI, because electronic signals for VORs are not affected by wind. So you need to put the magnetic course into your VOR, not the magnetic head. Let's see. You should be checking your directional gyro against your magnetic compass every 10 minutes of flight. Now, some directional gyros are really good, especially if they're new or they've just been overhauled, and you can fly a long time and they don't get out of sync with the wet compass. But as they get a little older, they get out of sync, especially if you're doing any maneuvering. And so if you've been doing maneuvering to start with, and then you're going to use the directional gyro to hold your heading to do an instrument approach, and the thing's off 20 degrees, guess what? You don't end up where you think you're going to end up. So checking the DG against the magnetic compass and correcting, and you have to do it in level flight, right? It is real important. How about rudders? Keeping flight coordinated. Okay, when do you need to use the rudder? I ask people that, and they say, well, I gotta use rudder anytime the ball isn't in the center. If the ball's out, I have to step on the rudder to recenter the ball. No. When you really need to use the rudder, whenever you displace the control wheel or the stick. If the ball is out, you're already too late. You should be preventing the ball from going out, not waiting for it to go out and then stepping on the rudder. Excuse me. So, when you displace the stick, at the same time, simultaneously, when you turn the wheel, you push on the rudder in the direction you want the airplane to bank. Don't lead with a rudder, don't do it later. Do it, the two controls together, the ball will stay in the middle, and your flight will be a lot more comfortable, and your passengers won't feel like you've got the leans. How about short field and soft field landings? How do you make them work? You don't have much runway to deal with. You want to land at the beginning of the runway. What do? Have to discuss aim point. The aim point and the touchdown point, where the wheels are going to touch the ground, are not the same place. The aim point is where the airplane would strike the ground if you just kept on descending into the ground. Now, we know very well you're not going to do that, right? You're going to flare and land. But once you flare, even slowed up for short field speed, the airplane's still going to float 150 to 200 feet down the runway until the wheels touch. So if you're landing on a really short runway and you want to use all of it, your aim point actually has to be short of the runway. And when you come down right at the end of the runway, then you flare and you float onto the touchdown surface and touch down. And short field landings are required, right, for private pilot or sport pilot. And sometimes students or applicants just can't get the airplane on the ground anywhere near where they say they're going to land it. It's because no one's told them that the aim point and the touchdown point are two different places. So you're doing a short field landing. How do you know if you're too high or too low? Okay, so you have an intended aim point, say where the numbers are painted on the runway, or where they started mowing the short grass runway. You gotta aim for some place. And you're descending. If that point that you have selected, the aim point, is gradually moving up in the windscreen, then you're gonna end up short of that point and you need to add a little power. If the point moves down in the windshield, then you're going to tend to be too high and overshoot it, and you need to take some power off. The point that stays stationary in the windscreen when you're descending is the place where the airplane would strike the ground if you didn't flare. If you're going to add power or take power off according to whatever you determine you need, don't forget that when you get back on the proper glide path, you have to set the power back where it was before. If you add power because you got too low and then you get back to your proper glide path, you got to take the power off or you'll change from being too low to being too high. And the same thing if in descent. So don't forget that if you change the power up, you got to take it back. You change the power down, you got to bring it back up again if you want to end up in the right place. Okay, so what is soft field approach speed? Every airplane, if you go to the landing distance table, they tell you at what speed you should be flying to do the shortest landing. And, okay, but it doesn't work for soft field stuff because you really want to touch down softly. You don't want the wheels to sink in when you hit the ground. And if you're doing short field work, you often, because you're slowed up, you often land with kind of a thud, which is acceptable for short field stuff if the ground is firm. So what really works in short field is add 5 knots or 5 miles an hour. Down in the 5s, it doesn't matter much whether it's a knot or a mile an hour to whatever the published short field speed is. So it's published at 61 knots, go to 66 knots. And then when you come in over the soft field, don't retard the throttle to idle. Set it for 200 RPM above whatever is flight idle. And so what's that? Okay, flight idle is the RPM setting that you get at idle, but when you're descending. And it's higher than sitting on the ground and bringing the throttle to idle. On the ground, most airplanes idle at something like 700 RPM, 800 RPM. But that same airplane with the throttle retarded all the way back will be turning 1,000 RPM with the airplane all the way, with the throttle all the way out. So, if in that example, you'd want to carry 1,200 RPM all the way to touchdown. When the wheels touch, bring the power to idle, let it roll out, and you have a nice smooth touchdown on that soft surface. Okay, here's these 8 quick ones, then we'll do some questions. You're going to make a turn your head and look in the direction that you want to turn, and then turn your head back and bank the airplane. Because if you turn your head to look to the left because you want to turn left, and then you bank the airplane, it's really hard to tell how much bank you have. So it's much easier to set bank looking straight ahead. The other thing you should do when you turn left to look for traffic, right, you're going to look where you're going to turn before you go there. Pick the point you're going to turn to. Pick a landmark, pick a house, pick a tower, pick a tree, pick something. Then look back straight ahead, bank the airplane. Then as the airplane comes around, when it gets to the point that you picked, roll out, and you'll have exactly the heading that you'd like. If you're doing it with a heading on the directional gyro, don't forget that you have to lead the rollout. In a typical turn, you have to start rolling out about 10 degrees before the heading you want to end up on. If you're doing a steep turn at 45-degree bank, which actually passengers hate, you have to lead the rollout by 20 degrees. I do flight tests, and applicants would constantly be turning the control wheel back and forth, back and forth. In level flight, they're just turning the control wheel. And if I asked, I said, well, why are you turning the control wheel that much? They go, well, I'm just trying to, I'm here in this test with you. I'm trying to fly the airplane perfectly. So I say, would you let me fly for a minute? And they go, oh yeah, because this applicant should always let the examiner fly if they want to fly. So the applicant says, okay, so I say, I've got the airplane, so I'm holding it, and then I put my hands in my lap. And I start touching it, and the airplane flies just fine. I say, so what are you doing this for all the time? The airplane wants to fly smoothly. You can't fix every bump. You're actually out of phase, and you're making it worse. So let the airplane fly. Don't try to fix every little perceived bump. You can't do it. Fix a trend. Sure, if the airplane actually enters a turn, you'll have to stop it from doing that. But don't saw the ailerons back and forth. All you're doing is wearing out the bushings. How about slips? Nobody likes slips except tail dragger pilots, right? I fly a Champ, I like slips. Boy, do I get to see ugly slips when I did check rides. And nose whips all over the place because people, roll the airplane to the left and apply right rudder, and it feels weird, and the airplane's cockeyed, and they don't like it. So then they relieve some of the rudder pressure, and the nose moves over, and then they go, but I'm supposed to be slipping. They pretty soon the airplane's going back and forth like this. Oh, God. Another one of them. Here's the way you do slips. First, you want to drop the wing on the side the wind is coming from. If most people in side-by-side airplanes, if the pilot's sitting on the left, want to slip to the left because you can see better. So they always slip to the left, and if their instructor doesn't tell them otherwise, they'll slip to the left on a check ride. But if the wing's off the right and we're going to land, now you have the wing the wrong way to compensate for the crosswind, right? And it's really hard to make that switch from having the wrong wing down up, putting the right wing down, the airplane's all over the place. It's ugly. So always drop the wing into the wind. Pin the rudder to the firewall. Just use all the rudder there is and make the airplane go, and then steer with the ailerons like the airplane was a pickup truck until you lose the amount of altitude that you want to lose. Then release the rudder pressure, level the wings, and land the airplane. Works much better. Be careful of airspeed. You don't want the airspeed to be real high because you come out of the slip, and guess what? It won't land because it's going too fast to land. So fly at the normal approach speed in the slip. So that's it for slips. Buckling safety belts. I see people really struggle to get their safety belts buckled, of all things. So while the door is still open, get your safety belts up and put them across your lap, because now you can get to them. They're not wedged between the seat and the door. Once you get your safety belts across your lap, if you have to integrate them with your shoulder belts like you do in my airplane, do that. But leave the belts loose. Shut and latch the door. Put the seat in, and leave it with the seats back. Then put the seat in flight position, tighten the lap belt first, and then take the slack out of your shoulder harness. And God forbid you have an accident, you have half a hope of staying in your seat, and you weren't fiddling around with your safety belts for a couple minutes trying to get them buckled. Shutting the door, speaking of shutting the door, when you pull the door shut, you're actually compressing air inside the cabin, even though the cabin's not pressurized. So in order to overcome that and get the door to latch, you really have to slam it. That's really hard on the latches. It beats the heck out of the doors. So don't do that. Leave the window or the vent open and close the door. Then you don't have to slam it real hard to get it to latch. And while you're at it, think about lubricating your door latches and hinges and maybe your seat rollers, because you know what? The mechanic doesn't do that for you. When they do the annual inspection on your airplane, that's not in the list of stuff that they're supposed to check, and they don't do it unless you specifically require them to do it, and then they look at you like you're nuts because they don't usually do that. It's actually owner maintenance. When you're taxiing around in reasonably calm wind, taxi with the control wheel back. It relieves the pressure on the nose strut, and you don't have to pay somebody to change the O-ring seals. Also, you're going to look at the nose strut anyway to make sure that it's properly inflated. If you have a rag with you, you can clean that oily dirt off it, and then you're not rubbing oily dirt up and down and again wearing out the O-ring seals in your nose strut. Leave the beacon on. You never have to turn it off. Since 1994, anytime airplane's equipped with a beacon, you have to have it on when the engine's running, day or night. Well, gee, The easiest way to do that is don't shut it off. So a transient surge won't hurt the beacon, and it's a really good reminder if you forget to turn the master switch off that you forgot, because you get out of the airplane and the beacon's flashing at you. You go, oh crap, I forgot to turn off the master, and you reach back in and turn it off. Even if somebody else says to you, oh, looks like you left your master on, well, that's embarrassing, right? But you know what? It's way better than coming back and finding out your battery's dead because you left the master on. Now, old school pilots, and I was trained this way because I've been flying a long time, they say turn off all the switches when you stop the engine. But modern day, most people leave their beacon on. Last thing, if you're an instrument pilot and you get vectored onto a final approach course, sometimes either you screw it up if you're doing the approach on your own and you don't turn in time, or sometimes ATC will give you a late vector and they'll fly you through the course. If it becomes apparent from your instrument indication that that's what's going to happen, it's okay to bank a little steeper. When we fly on instruments, we do standard rate turns, right? And you're not turning very sharply. But it's okay to go, say, from that 15-degree standard rate turn bank to go up to, say, 20 or 25 degrees. Now, I'm not suggesting aerobatics on instruments here, but you can make approaches work out a whole lot better if you hurry the turn a little bit in order to avoid flying through the final approach course, and then you have to fix it. Okay, so that's the end of the formal part of the presentation. Anybody have questions? Want to talk about any of this? Oh, thank you. I need that. Yeah, no, this is like the... I was listening to Dave Lighting do a presentation. Sure. Thanks, Rick. I was listening to Dave Lighting do a presentation this morning in the Learn to Fly Center, where I'm doing a presentation tomorrow, and he goes, anybody have any questions? And like nobody raised their hand. Can't get it. There we go. Somebody's going to save me. Please.
So, I'm fortunate enough to be able to fly a couple different airplanes, and one thing that I found really helps me is just to review everything for each aircraft, to take the time to go through the checklist, and to just make certain that I'm flying the right aircraft. That just helps me to remember, because the planes I fly are quite a bit different from each other. And anyway, that's just something that I take the time to do. I don't get in a hurry. I make sure that I follow the checklist and make sure that it's correct.
Yeah, you know, and that's really good. I flew high-wing Cessnas for years, and I owned a 172 for like 16 years. And I got really complacent about the airplane, and I actually got where I didn't use my checklist very much. And I generally didn't forget stuff. But then I came up in the world and I got a 182. Well, that's considerably more airplanes, more stuff you have to worry about. Only my bad checklist habit carried over, and I found myself forgetting to do stuff. You know, like taking off of the cowl flaps closed, for example. And it's like, oh, wait a minute, dumbass. You're about to either do something dangerous or cost yourself a lot of money. And I started using the checklist, and I use the checklist now every time I fly an airplane. I've been flying my Champ since 2011. I don't fly it without getting out the checklist and using it. Thank you very much. Good recommendation. Who else? Okay, there are no other questions or comments. Thank you very much for attending. We appreciate it. Have a good show.
The wings form, you need to bring them up here, I'll come by and get them. Thank you for attending.